Okay, hi. Yeah, thank you for coming to the last session on the last day of NDC. Really appreciate it, whether you're here in person or remote. I'm curious if anyone is coming in cold. Who hasn't heard of Microsoft Mesh before? Okay, so yeah, a few people. And who here has tried the HoloLens 1 or the HoloLens 2 before? Yeah, so yeah, most people. Okay, great. So yeah, I'm talking about Microsoft Mesh and the HoloLens 2, and specifically I'm going to talk about what Microsoft Mesh is and why it needs to exist, what problems it's solving for users and what problems it's solving for developers, and how you can get prepared now for the release of Microsoft Mesh, and hopefully get inspired to get started on that journey. So a little bit about me. I'm Scott Leaman. I'm the mixed reality lead for Sopra Steria Norway. I'm also a Microsoft MVP for mixed reality. And I started off my life at the bottom of the world in Tasmania, in Australia, and I've worked my way up to Norway, at the top of the world. But I also stopped off in Seattle for a couple of years when I was introduced to the Microsoft HoloLens in 2015. And I've been working with mixed reality ever since, so the past 6 years. So the mixed reality, what is mixed reality? A lot of you already know, you've tried it, you know what it is. But for those who haven't tried a mixed reality device, mixed reality is this spectrum between the real world and the digital world. And on one end, you've got virtuality, where you're cut off from the real world. You're in a imaginary world with no stuck rules. And then you've got augmented reality, where you're having to deal with the real world, but you're adding in or mixing in digital elements. And the HoloLens 2 is on that side of the spectrum. This is the HoloLens 2. It's a wearable computer. It doesn't attach to anything. It contains all its own storage and compute. And it doesn't have a traditional display. It has a transparent display, so you can still walk around, see the world, talk to people, look people in the eye. But you're seeing digital objects or holograms embedded in the real world. And it's got a lot of sensors. It's got 8 cameras, 2 eye tracking cameras, 4 cameras that are looking around in the environment, tracking how you're moving, and it's got 5 microphones. And it's using all these sensors to orientate yourself and to try and interpret what you want to do. And it uses all those sensors to do this, to embed holographic objects in the real world, particularly for work. So it's not an entertainment device. And you can also look at holograms together using multiple devices. And this is a big part of what Microsoft Mesh is trying to enable, is these sorts of collaborative scenarios. And this is how you interact with the HoloLens 2. You're using your hands, so you can press holographic buttons, and you can reach out and grab holographic objects and move them around. But what's the point of that? What does that give you that computing on a traditional screen doesn't give you? One thing that you can do using mixed reality devices like the HoloLens 2 is you can embed data in the real world. So in this case, I'm going to go through a couple of projects, example projects from Sopra Steria. This is a project where we took the 3D plans for a building and embedded them on the construction site. So you're able to be on the construction site in the real world and look at what is planned to be built. You're able to say, this is what we're planning to build, and this is what we've actually done so far. And do they line up? Have we made any changes already? Have we deviated from the plan? And you're able to see things within the walls and within the floors. And so that's a way to empower the people that are working in the real world and don't traditionally have access to this sort of information in this way. So it's a way to give people out in the field digital superpowers. So that's one way mixed reality can be useful, to take data into the real world and place it in a way that is meaningful and useful for people. Another thing that mixed reality is useful for is for looking at things that are innately 3D. So there's a lot of objects in the world that are 3D, 3D machinery, 3D places, and 3D anatomy. So people are 3-dimensional creatures. But when surgeons are planning for a surgery, they're looking at a 2D screen most of the time. They're looking at 2D medical imagery, a number of slices on a 2D screen, and they're using their imagination to turn that into a 3D image in their head. Each surgeon is looking at the same 2D image and saying, well, this is what I think it is actually going to look like in 3D, but they don't know until they open up the patient if they're correct. And they can't really compare their mental 3D models with each other or have a meaningful communication in 3D. So for this project, for the HoloCare project, we're taking the patient's 2D medical imagery and turning it into a 3D hologram that multiple surgeons can look at the same time and have a conversation. And this is what that looks like, where you've got multiple surgeons, they're looking at the same hologram at the same time. This is a hologram of a patient's liver with a tumor that needs to be removed, and they're able to have a conversation as if that were a 3D object in the room. They're able to point at what they want to talk about. They're able to have the same, and same for heart surgery, the same experience of what this 3D object looks like, what the structure of the organ looks like, and have a conversation about how to approach the problem. And of course, we've also enabled it so that specialists from other cities and hospitals can be present in those planning sessions as avatars. And so you have people represented as these avatars, and they're using the hand tracking on HoloLens 2 to allow them to emote and point to things, and you can hear their voice coming spatially from that avatar, and you're able to have a conversation in the same room together, remotely, to discuss the structures of the heart or the liver. And finally, this is a more experimental project around holoportation, and this is where you're capturing a person in 3D. We're using a depth camera called the Azure Connect, and then we're displaying that 3D capture in real time on a HoloLens 2. So it's a volumetric video communication. So it's like a live Star Wars style hologram of a person. And the purpose of this sort of project is to get closer to real life communication, closer than you can get via video conversations. So when you're in the room, it's hard to see on video, but when you're in this room with a live hologram of a person, it triggers all the social cues. So you want to give them personal space, and you want to look them in the eye, and you want them to look in the eye. So you're acting to this hologram not as a video, but as if it were a person in the room. And now I'm going to talk about one of the challenges of mixed reality, and this is very relevant because this is one of the core things that Microsoft Mesh is trying to solve. And this is the problem of, okay, if we're placing digital objects, holograms in the real world, how do we locate them? How do we specify there should be a hologram there, and it should be there for me, and it should be there for you? So this is a 17th century map of Scandinavia, and it doesn't look like such a safe place, particularly off the coast of Norway. There's a lot of sea monsters there. And this is an example of the phrase, "here be dragons," that people used to draw maps with monsters in uncharted and potentially dangerous areas. And nowadays we like to think, okay, we're maybe gone past that point because we've got Google Maps and we've got GPS. But GPS is only accurate in terms of meters, and it doesn't work effectively inside buildings. So we've still got monsters in the buildings, effectively. Those are still unmapped and potentially dangerous areas. And this is a problem because, in terms of placing holograms. So how do we place holograms in the world? And like boats, if you don't anchor a boat, you can't expect it to be there the next day. It'll float away. It's the same with holograms. If you don't anchor a hologram to a particular point that's immovable in the real world, you can't expect it to be there the next day to persist. So there's different ways of anchoring holograms. You can anchor it to a fiducial marker, an image that the HoloLens 2 can recognize consistently and accurately. So you can use a QR code, or there's a number of other computer vision solvable image recognitions systems that you can use. And then if you recognize that image, you can place holograms relative to it. And it's very reliable, it's very accurate, but it means you have to mark up the world with all these images, which isn't always ideal. Another thing you can use as anchoring is the spatial mesh that the HoloLens 2 generates of the world around it. So it's tracking you as you're moving around. So it's doing a real-time 3D mapping of the space that you're in. So in this example, it's mapping the bench and the chairs as I'm walking around. And in the end, you get a 3D mesh, something like this. And you can use this to do some anchoring. You can anchor holograms to this mesh. You could say, okay, there's a chair there. I want to put a holographic person in that chair. And then if you're in the same space and you recognize, you look at this mesh and you say, oh yeah, I'm also in this space, you can also have a holographic person in that chair. So that's another way to anchor holograms. Because ideally what you want is you want to have a immovable point specified somewhere in the real world. Okay, that's 2 meters from this wall, 3 meters from that wall. You want that anchor to not move, and then you want to place digital content relative to that anchor so that you can put digital content in meaningful and useful and replicable places in the world. And if you can do that, you can come into a space, recognize some sort of unique fingerprint, and place a hologram, say a holographic gem, on one device, and then another user comes back at another time, they recognize that fingerprint, and they're able to recall the position of that hologram in the same place. And then you can also do that simultaneously. If you all have a shared anchor, you can say, okay, we will all see this holographic gem in this location, and be able to collaborate around that digital object. So this is part of the part of the problem that Microsoft Mesh is trying to solve. And if that can be solved, then you can take the monsters off the map, and you can start filling the world with useful things, like 3D models of buildings and live sensor data. You can start to do really interesting collaborative experiences. So you can collaborate across time. You can leave digital objects in the world for others. Like if you're doing maintenance on a real-world piece of equipment, you can tag information onto that real location. You can have collaboration in the same space, so you can design together, or surgeons can discuss a surgical problem together, or do design together on new products. You can also collaborate across space. So maybe I'm in a factory working on a particular problem, and then I have a remote expert that is helping me solve a problem and adding holograms into my world. So there's all sorts of opportunities for collaboration that open up once you have that anchoring problem solved. So Microsoft Mesh. I'm going to start off with a vision video from Microsoft that they released when they announced Microsoft Mesh. And I'll talk through it, and then we'll dig into the components of Microsoft Mesh. So here we have two different users, both wearing HoloLens in remote different locations. And one user is holoported into the other's location so they can have a spatial collaboration. And then we have another person who's learning calligraphy remotely, so that person and also objects are being teleported in. And here you're having people in the same space, collaborating. The same here on different devices, on tablet, on HoloLens 2. And then also other people remote being brought in as using holoportation. And then finally, we've got air traffic controllers, where we've got a person seeing others as avatars and holoportation. And they're collaborating on a spatial problem, the air traffic problem. And one of the users is collaborating via VR and appearing as an avatar. And then finally, people collaborating in the same space, while other people are also collaborating via avatars. And so all these examples are examples of how Microsoft Mesh is trying to solve this problem of location using mixed reality, that you can collaborate in the ways that aren't currently possible with video conferencing using mixed reality. So Microsoft Mesh is a mixed reality collaboration platform and a development SDK on top of that. It was announced in March this year at the Ignite conference. It's not yet released. And it's because it's Microsoft, it's all based on Azure. And it's designed to support not just the HoloLens 2, but also VR and smartphones and tablets and also PC. So there's like a range of devices that are designed to be supported. It's not just a HoloLens 2 platform. And some of you may have seen a couple of weeks ago, Microsoft announced that Microsoft Mesh is coming to Microsoft Teams next year. So starting next year, you'll have the option, instead of using live video feed or a picture of yourself, you can participate as an avatar. So you can participate as an avatar via a VR headset or via the HoloLens 2, or even just using your webcam to track your movements and have them be reflected on the avatar. And you can also have meetings in 3D environments, in spatial environments. So that's going to be interesting to see. I think that's a really interesting way to introduce people to these tools, regardless of what hardware they have. So Microsoft Mesh, the development platform. The development platform has to exist because whenever you're trying to build mixed reality collaborative experiences, you're usually bumping up against some of the same problems. No matter what domain you're working in, there's a few common problems that you have to solve in order to get them to work. One of them is that if you want to load 3D models into your application, it can be non-trivial. There's a lot of different formats depending on the industry. Okay, it's coming from the building industry or it's coming from the health industry. You have to maybe do some conversion. You have to think about performance. Okay, is this 3D model actually going to render on the device that I have? So dealing with all the different levels of detail and all the different file formats for 3D models is something you have to deal with. Another problem is that, it's hard to represent people in 3D. Whether you're using avatars or another system, it's not a trivial problem in terms of development effort in order to solve that. And another is the anchoring problem. How do you anchor things so that people are seeing things at the same time, at the same place? And the last one is how do you synchronize all the actions of all the users? So basically networking. So there's a lot of networking solutions out there, but they're not always optimized for mixed reality, and it's not necessarily something that's like trivial to implement. So this is the point of Microsoft Mesh for developers, is that it's designing to cut down the complexity of mixed reality development and solve some of these common problems that you always have to solve no matter what application you're building. But from the user side, the point of Microsoft Mesh is to allow people to feel presence, even when they're remote, to allow them to experience things together from different places, and to be able to connect from different devices. So it supports HoloLens and VR headsets and tablets and phones, but also PCs. There's a development platform that I'll dig into, and then there's apps that are using the Microsoft Mesh platform. So there's a showcase application for the HoloLens 2 that is already using the Microsoft Mesh platform. There's AltSpace VR, which is a VR social space social application that Microsoft has bought that is traditionally focused at consumers, but now Microsoft has branched a version for the enterprise, so you can sign in with your enterprise credentials and have work meetings in VR. And Microsoft Mesh is coming to Teams as well. And then there's going to be a wave of mixed reality applications that are built on the developer platform once it's released. So the platform has got three main parts. One is the core platform, and this is things that you need for mixed reality collaboration applications, but that are not necessarily mixed reality specific. These are things that you might need for any sort of application. And then they've got a series of capabilities that are mixed reality specific. Like there's 4 problems I talked about that you always have to solve. Those are focused on solving those problems. And then you've got a toolkit on top of that that allows you to interface with the capabilities in the core platform. So on the bottom, the core platform, it's got all the plumbing that you need to worry about. Okay, if we're having a collaborative session, how do we control the session? Who controls it? What are the users that are allowed to enter? How are they authenticated? How is billing handled? Streaming of audio and video, and all that sort of things. That's handled in the core platform. So this is all from Azure, so if you're already using authentication and so forth in Azure, you know how this stuff works. And then there's the mixed reality specific capabilities, which build upon that core platform. And that's immersive presence, which is how do you represent users to each other, spatial maps, how do you anchor holograms in the real world, holographic rendering, how do you deal with all these potentially complex 3D models, and then multi-user sync, the networking problem. And you interface with the core platform and the capabilities via the Mesh SDK, and you also get a series of UX constructs, which are common UI elements that you might want to use in collaborative sessions, such as drawing in space or loading 3D models, a menu for loading 3D models. So you'll get some example UX examples as part of that. And the capabilities. So to dig into immersive presence, so there's going to be an avatar system. And an avatar system is there's kind of 2 parts. There's the input and the output. So different users are going to be having different devices. Some users might be wearing a HoloLens 2. and that's got tracking 21 points on your hand, so you've got very precise hand tracking. It's tracking your eyes, it's tracking your head. And then other users might be using, say, an Oculus Quest, and there it's not really you're tracking controllers. You might not get individual fingers, depending on what the user's doing. You're getting the head tracking, but not the eye tracking. And then other devices, they'll have, you'll have no tracking. Maybe they're just controlling the avatar via PC. And so the avatar system takes that input and tries to fill in some gaps to make some reasonable assumptions. Okay, maybe you know where their hands are, but you don't know where their elbows are, so you're going to have to do some intelligent guessing there that the elbow isn't up here. And so that's the input side, and then there's the output side. Not everyone has the time to build their own customizable avatar system, so they're going to provide a default avatar system that you can use or not use and build in your own avatar system if you want. And then there's the photorealistic holoportation, dependent on external sensors like the Azure Connect, and then all the interactions between the users. You want the users to be able to say, I take an action and that's reflected for everyone else, and I can hand a holographic object from one user to the other. And to look at the avatars for a sec. So this is not an example of the default avatar system, but this is what most avatars look like, a simplistic, maybe cartoony representation of a person. And there's a reason a lot of avatar systems go that way, is because if you go too far along the right on the realism spectrum, it can start to look like you're puppeteering a corpse. You get into the uncanny valley area, and it can be uncomfortable. So having more basic, simplified avatars can be a great way to go, and it's very democratic because you don't need any special sensors or anything in order to be able to control that avatar. On the other end of the spectrum, on the very realistic side of the spectrum, is holoportation, where you're capturing someone volumetrically in 3D, and that's less. It's of course much more realistic. It's much more like being in the same room with someone, closer to the real life experience, but definitely trickier from a technical perspective. It's a lot more data that you're having to transmit, and it's required on specialized hardware. Some people have got 3D cameras in their phones and some don't, but most people don't have, say, Azure Connect in their home or other volumetric capture systems, so it's got a lot less reach. In the future, the holy grail is to try and do something that's both, that you can have very realistic representation of yourself to other people, but right now it doesn't have a lot of reach. So we're reliant on things like avatars. And now I'm going to talk about the Mesh app that came out in preview back in March when Microsoft Mesh was released. And this is an app on the HoloLens 2 that is running on the Mesh platform now. So it's a great showcase of the capabilities of the Mesh platform. And it's a social app. So it's a social app for having some sort of collaboration, whether in the same room or remotely with up to 8 people at the same time. So these photos and videos are taken from the HoloLens 2. And the first thing you have to do is to build your own avatar. If you've ever built a Me or an Xbox avatar, you know the drill. You pick your hair color and your face shape and your body size and the clothes you want to wear. And then this is how you're going to be represented to other people. And then in the app, this is what it looks like. So you've got a life-sized avatar that you're seeing. And this is reflecting what the user is doing. So as they move their hands, you're seeing the avatar move their hands. As they talk, you're seeing their mouth move. The HoloLens 2 has got eye tracking, so you're seeing their eyes moved to see what they look at. But you can also collaborate with people locally. So you can have these meetings with people in the same room or remotely or both simultaneously. So here, I'm in a meeting room with a real person, while also having other people come into the same meeting room and into the same space, being represented as avatars, and we're all having a conversation together. And we can load 3D models into this meeting. We have a holographic table there, and we're able to load in some 3D models and manipulate with our hands and have a conversation around those models and hand them back and forth and so forth. And because the avatars are representing the hand movements and the eye movements and the spatial location of people, you can get quite good readability of what's going on. Of, okay, this person is showing this 3D model to someone else. Okay, they're handing it back and forth. So it's a great way to to collaborate around 3D objects in particular. And you can also draw in 3D as part of this app. And this is what it looks like to draw in 3D with your hands. So it's very easy to learn. And you can draw together, of course, and collaborate on drawing together. Are there any guesses to what they're drawing? Yeah, it's a snowman. Yeah, including with animated snow. And it also includes the ability to do remote rendering. And so if you're familiar with the concept of, or the product Xbox Cloud Gaming, it's similar to that. So this motor that's been shown here isn't being rendered on the HoloLens 2. It's being rendered in the cloud and then streamed as a video into the application. So it means that you can load 3D models into the app that you wouldn't normally be able to load because they're too complex. And so if you look at this motor, this example model, it's got some details that are like very detailed, physically modeled details. So like the threads of the screw have been physically modeled. If you were looking at this motor in a game or something, they wouldn't bother to model those details because it's overkill, it's too much. But for people that are engineers or product designers, these details are meaningful. So it's a way to see these details without simplifying. And I'll come back to remote rendering. But you can also load in things like 3D scans of places. So this is a scan of one of the floors of Soprasteria, where we've done a quick scan. It's very quick and unoptimized. So we're not optimizing to make it the most efficient model in the world, but we're able to take that incredibly detailed 3D model and see it within the app using remote rendering. But you can treat it as if it was a local object. So you can reach out and still move it. Treat it as if it was actually on the local device. So the Mesh app for HoloLens 2 is the best example right now of what the Microsoft Mesh platform is going to be able to do. It shows example of local anchoring, that you're able to anchor holograms in the same space and look at them together. It shows remote collaboration using an avatar system that is taking input from the device and then reflecting it via a customizable avatar. You're able to do all the multi-user sync, and it also includes remote rendering for complex models. And now I'm going to talk about mixed reality services. And these are services that already exist in Azure that are intended for mixed reality use. And I'm going to talk about them because these services fit very nicely into the spatial maps and the holographic rendering capabilities of Microsoft Mesh. So I think it's reasonable to assume that these services, or some variation of these services, might be part of Microsoft Mesh once it's released. Maybe not the exact API, but definitely these concepts will be relevant for Microsoft Mesh. So there's 3 services: spatial anchors, remote rendering, and object anchors. I'm going to talk about spatial anchors first. And these are, these are very important. This is very important to the anchoring problem for mixed reality. So a spatial anchor, like we talked about, it's a point, an unmovable point in the real world, 2 meters from that wall, 1 meter from that wall. And the idea is that you can, once you have that point, you can attach holograms to it. But that anchor is not itself a 3D model. It's just a place in the room that you can attach 3D models to. And the point of Azure Spatial Anchors is to have a very lightweight, very small bandwidth anchor that you can pass around to different users. So you can very quickly create an anchor and then say, OK, you guys can have the anchor as well. And then we can very quickly, say, collaborate and see the same holograms in the same place. And this is what it looks like behind the scenes, this series of dots. So what the service does, whether you're on the HoloLens 2 or another device, it looks around at the space that you're in, and it picks out feature points. So these could be the gaps between physical objects, or it could be an area of high contrast. And it's using that to make a sparse point cloud of the area. So this is like a 3D fingerprint of the space. So it doesn't send any photos or videos of your location to the cloud, but it sends this sparse point cloud. And then you don't really get it back, but you can check against it. So it's like a 3D fingerprint that you can check against and say, hey, am I here? Am I matching against this fingerprint? And if so, you know you can get an anchor and you can attach holographic content to it. But the location matters, of course. Because you're generating a 3D fingerprint of the area matters. It's using things like features from the furniture and images from or textures from the wall. So if you use it, try and create a Azure spatial anchor in an empty room with nothing on the walls and nothing on the floor, it's not going to work very well because it's not going to be a very unique fingerprint. And the Azure spatial anchor services is very well, it's the most well supported across platforms of the mixed reality services. So it works across HoloLens 1 and 2, but also across iOS and Android. So that means you can create an anchor on an iPhone and then load it on HoloLens 2. And that's one of the use cases that you can use it for collaboration. So you can have one user using, say, a tablet. They're creating an anchor, placing an object relevant to that anchor, uploading that to cloud, and then another user is downloading on another device, and then they can very quickly see the same content in the same place, and they can collaborate together in real time. Another use case is just persistence over time. So one user places a holographic car on a table using one device. That information is sent up to the cloud, and then another user comes back another day using another device like the HoloLens 2 and sees the same content there. So it's as if the 3D object lives in that space. And then also wayfinding, because spatial anchors can have spatial relationships. You can say this anchor is 5 meters in this direction from this other anchor, so you can use it for wayfinding. If you find one anchor, you can direct users to find other points of interest in the space. So you can use it for indoor GPS-like navigation. And that's relevant to a lot of industries. So it's relevant to manufacturing because you can add, say, IoT information in the right location. You can leave task lists or relevant information attached to machinery. It's useful for retail because you can use indoor navigation to guide people through the store. You can have a collaboration with a customer about some product customization using different devices. Maybe you're steering something on a tablet and they're seeing the result on the HoloLens 2. And it's useful for education as well because you can give people guided tours through museums or have students looking at the same 3D model at the same time and having a lesson that way. And it's useful for architecture and construction because you can do design reviews together in 3D. And you can also bring those models to the construction site and line them up with reality. So that's available now, and it's available across a lot of Azure regions, supported across a lot of platforms. But you're connectivity dependent, so you need connectivity both for saving and loading of Azure anchors. And then another service for anchoring the world is Azure Object Anchors. And while spatial anchors is about anchoring in a particular place, Object Anchors is about anchoring to a particular object. And it's only supported on the HoloLens 2. How this works is that you have a 3D model of an object, say a car or a large boiler, and you upload that 3D model into the cloud and does some processing, and it generates an object model that you download to your device, and then you can match against that device in high precision on the HoloLens 2. So it's a great way to do very high precision locking of holographic content against real-world objects, but there's a size restriction. So the objects have to be more than 1 meter and less than 10 meters in every dimension. And they have to be rigid. They have to be rigid objects for you to be able to match against them. So a car is a great example. So Toyota uses this technology for their service technicians. So they have a 3D model of this car. It's their car. They've uploaded it to the cloud, generated a object model they can match against on HoloLens 2. And then once they've matched, they can see the internals of the car, or the service technicians can see the internals of the car to help them do their job. So they can see different parts highlighted as they're doing their work. And this is a great use case for object anchors, for adding holographic training instructions or holographic guide instructions or helpers, or for logging information against the real-world object to say, okay, I did some maintenance against this object. I want that record. Maybe you record a video of you doing the maintenance. Let's attach that to the real-world object. But because you're depending on a rigid model to detect against. If you opened the car doors, it maybe wouldn't match. So if you wanted to have a car with doors open detection, you'd have to create another model and upload that and say, okay, let's look for both these models at the same time. And that's available it's in public preview now, so it's a free service. So it's not available in many regions, but it is free for people to test out. And that is that's dependent on connectivity for the uploading of the model, but then once you have the model, you can use it offline. And finally, remote rendering. So remote rendering is that service that we showed before, being used in the Mesh app on HoloLens 2. And this is dealing with the complexity problem of 3D models. This is also only available on the HoloLens 2 at the moment, this service. So this is a 18 million polygon model. And if you don't work with polygons a lot, they're the three-sided shapes that make up 3D meshes. And they're kind of like the atoms of 3D meshes. So if you follow the history of video games, a lot of the history has been about getting more and more computing power in order to draw more and more polygons. So the more polygons you can draw, the more realistic objects you can render. So early video games were very blocky and had very blocky people, and as the computing power got more powerful, you could have more realistic graphics. So 18 million polygons is too much for the HoloLens 2 as is. So the HoloLens 2 can handle without dropping performance about, say, this other model here, so 250,000 polygons. Or you can go a bit higher, you can maybe go up to 1 million, depending on other aspects of the 3D model, the materials you're using, the textures you're using. But this is about the safe range that you can get away with. And there's a problem if you drop performance. Because the HoloLens 2 is a head-worn device, it's trying to keep a very high frames per second. It's trying to keep 60 frames per second. And if it needs to have a consistent 60 frames per second in order to have this ability to anchor 3D objects in the real world. If this water bottle is a hologram, and I'm moving around normally and displaying at 60 frames per second, okay, it stays there. But if I drop down to 20 frames per second, suddenly when I move my head, the water bottle moves with me, because it's not able to redraw it where it should be fast enough to maintain that illusion of it being anchored in the real world. So if you get down below 60 frames per second, it starts to affect the user experience, and it's bad. It makes holograms appear shaky. So this is a problem. And so one way you can solve this problem is by simplifying the model, as they've done here. They've reduced it to polygons using a method called decimation. And that's where you use some algorithms that you choose to remove polygons. And in this case, the result is not so good. It definitely doesn't maintain a lot of the meaningful information that you'd want to see, particularly if you're doing design analysis or your engineers talking about the design of this motor. It's not really good enough. So that decimation process, it removes stuff from the model. And if you had a doctor say to you, hey, we're going to remove some stuff from your body, you might say, well, what stuff? I've got higher priority stuff and lower priority stuff. Let's get specific about the stuff. But with decimation, it's hard to specify that. It's hard to say, these are the features I want to keep, and these are the features I'm willing to lose. So you're kind of, it's a hard process to manage. And so Azure remote rendering is an alternative to that process. If you want to show this content on the HoloLens 2 in all its glory, with all the detail at 18 million polygons, using Azure remote rendering to render it in the cloud in Azure is one way to do it. So on the HoloLens 2, natively, you can get around 250,000 to maybe 1 million polygons without affecting performance. Using Azure remote rendering, the standard tier, you can get up to 20 million polygons. And then there's also a premium tier where you can go up to, say, 1 billion polygons. And how this works is that you have the model that you want to show, say in this case a robotic arm, and you upload it to Azure. And it's going to go through some processing. It's going to convert it into an ARR model in the cloud. And you can do that either via Azure Remote Rendering API or PowerShell, or there's a graphical tool called Azure Remote Rendering Asset Tool. So you upload the model, it gets processed into ARR format, and then in your app, you say, let's start a session. And this is you saying to Azure, give me a lot of rendering power right now, as fast as possible. And then you load in the model, and it'll start rendering. So it'll start sending 2 simultaneous video streams to the HoloLens 2, 1 for each eye, and it'll also send you a depth buffer. So you can say, OK, I know the distance this model should be from my face, so I can occlude it. I can put other objects in front of it or behind it. And then in your app, you're doing a composition where you're saying, this 3D model, robotic arm, is being rendered in the cloud, but I've got this menu that I'm rendering locally, and I want them to be combined for the user. This is what that looks like. This is that 18 million polygon model of a motor. And this model isn't really there, of course. You might say a hologram isn't really there, but this really isn't there, as in it's not that model, that 3D model isn't on the device. It's not in the engine. It's not on the HoloLens 2. It's being rendered in the cloud. So the application knows, only knows about this model what the Azure Remote Rendering Service tells it. But you can still manipulate it as if it were there. So you can manipulate, you can move around, you can manipulate the parts of the model, the different transforms. So you can take it apart, piece by piece. And with a good internet connection, it feels as if it's being rendered locally. There's no break in that illusion. It doesn't support, the service doesn't support animations, but because you can manipulate the transforms, you can do programmatic animations. So you could do, say, an explosion and have the parts of the motor explode out so that you could inspect all the individual parts if you wanted. And it has this composition of things that are rendered in the cloud and things that are rendered locally. So this menu isn't particularly performance intensive, so you can render that locally and then combine that with this cloud rendered model. And then have them interact together in a reasonable way. Because you have that depth buffer, you can say, this is how they should interact, even though one of them is only 2 video streams instead of a real 3D model. And then you can change the materials, which is the surface properties of the different parts of the 3D model. You can say, you can highlight components or change the color of components. And then finally, Azure Remote Rendering also exposes a cut plane tool so that you can cut into the insides of the 3D model. So if you've got a model of a building, you can cut into it and see the insides, or the insides of an engine in this case. Yeah, I love it. I think that's really cool. And that's available now, only for the HoloLens 2 at the moment. And obviously, you're dependent on a good internet connection. So it's good that your performance, because you're streaming video at high speed, the service is getting your head position and then doing estimations on where your head is going to be by the time the video gets back. So your experience is definitely affected by your internet connection. Although earlier, when I was showing the mesh app on HoloLens 2 and showing the scan of one of the floors of my office, that was tethered to 4G. So that can also be good enough. So to sum up, Microsoft Mesh, it's not a product, it's a platform. It's designed to be invisible to users, to be the platform and the development kit behind different applications. But it's designed to allow you to do amazing things, to move beyond simple video calls and to start having people and places and things being more portable in a way that they haven't been before. So you can get closer to in-person experiences digitally. So going back to these 2 projects, Sopra Steria projects, we spend a lot of time, the mixed reality developers at Sopra Steria, solving some of these important mixed reality problems. How do you anchor things in the real world reliably and accurately? And how do you enable collaboration between people both locally and remotely? These are fun, challenging problems, but it takes a lot of time. And you have to solve these problems no matter what domain it is, whether it's the construction side or the medical field. And so the promise of Microsoft Mesh for us is that, okay, we don't have to worry about these repeatable problems that have to be solved in order to allow mixed reality collaboration, we can just turn those features on in a way, and then focus on, okay, what's the value for these specific domains? What's the value for the construction side, or what's the value for the surgeons, and focus our development time on those problems rather than general mixed reality problems. So that's really promising for us. And it's really promising for us for user testing as well, because even if an application doesn't need collaboration for whatever reason, one of the ways that we test these applications is by, for the holographic, for example, when we're talking to surgeons and talking about new features and testing them out, we'll often have conversations with them from within the application. So they'll be using the application, working on testing out a feature, looking at a particular organ, and we'll be in there as well, either locally or remotely as avatars, and going through the application with them, seeing what they're seeing, and having a conversation within the application. And that's a great way to test. And it's something you need to do for mixed reality applications is always test with the people that are using the applications, and always test with them in the environments that they work. Because you're not working from a screen, you're working on the construction side or maybe the operating theater, and so it's so important to have a very tight feedback loop with the users. And so we think Microsoft Mesh is going to make that process of testing. When you develop an application, you don't necessarily get networking in as the first thing. You don't go, okay, let's implement networking and then let's implement features. Sometimes you have to, networking and the collaborative features can come a lot later because it's a series of problems you have to solve. Okay, how are we going to anchor things? What networking library are we going to use? So this is we see it as giving us great potential in terms of testing and iterating on applications in mixed reality as well. So Microsoft Mesh, it's been announced. It's not out yet, but it's coming to Microsoft Teams next year. If you've got a chance to try out the Mesh app on the HoloLens 2, that's the best way to get a sense of what it's capable of right now. But if you're not able to do that, it's great to check out the documentation at aka MS Mesh Docs. But probably more in depth is to dig into the existing mixed reality development tools like Unity and Unreal and StereoKit, and in particular the Azure mixed reality services that are already available, because those services are going to be, the capabilities they allow are going to be very transferable to Microsoft Mesh. Yeah, thank you. Are there any questions?
Point cloud you had, hologram. Could you use two cameras and at different angles and get a wider area?
Yeah, definitely. You're talking about the holoportation, capturing people. So the question was, with holoportation, where you're capturing people, the example we used was one depth camera, the Azure Connect, you're capturing someone in 3D. Could you use multiple cameras and capture people from multiple angles, get a wider area, maybe see more of the person? And yeah, absolutely. And that's, we're not the only company that's doing or trying holoportation in the world. Microsoft, it's going to be part of the Microsoft Mesh service, but Microsoft has been doing experiments with holoportation for years, since very on with the HoloLens 1, and they'll use different camera arrays to capture people 360, and that's, they've had like kind of $1 million setups, and they have mixed reality capture studios in a few locations in the world where they have those setups. So you can, those are for more recording people, pre-recording people, having a high quality 360 recording of someone that you can play back later. But yeah, there's definitely systems for combining multiple cameras, and there's different companies that are trying to do it real time as well. And if you do it real time, you have some interesting problems to solve. Like yeah, exactly. How do you combine these multiple 3D streams? What data do you throw out? And how do you mesh them together? So yeah, you definitely can, and it's an interesting problem. And but it's a question sometimes of if it's worth it, because you're kind of trading a more complete mesh for inconvenience. One camera is kind of inconvenient enough. Do you want to set up 10 cameras? a camera above them, different cameras. It's definitely possible, and I think it depends on the use case, what's best. Sometimes one camera is enough, because generally when you want to have a face-to-face conversation, okay, you want to see their face. So it might not be so meaningful to capture them from the side or other angles. But of course, if you don't do that, you're going to get some bizarre artifacts. Like if you put your hand in front of your chest, okay, one camera suddenly can't see the behind your hand. Now you're going to have a hole in your chest. And there's ways to get around that as well, to like fill that in intelligently. But it's kind of compromise about, yeah, how many cameras you should have depending on what experience you want to have.
Interior mapping, as an example, is it's a pretty private data set.
Yeah.
Do you have any thoughts on how to secure that kind of data?
It's yeah, it's a really interesting problem. Do you mean, sorry, the question was with internal mapping of internal spaces, that's really private data. Do I have any thoughts about securing that data? Was that in reference to Azure Spatial Anchors specifically, or more generally?
Yeah, no, in reference to Spatial Anchors, especially if you connect them to a GPS point, for example.
Yeah. Yeah, absolutely. And Azure Spatial Anchors, so because it's supported on mobile, you can definitely attach GPS coordinates to those anchors. And that's one way you can find anchors. So you can have, it's called coarse real allocation. So if you're using Azure Spatial Anchors on mobile, you can walk into an area and say, okay, these are my GPS coordinates, approximately, 7 meters each way, approximately, on your phone. Are there any anchors nearby? And that can help you know, okay, which anchors should I look for? You're still using the visual identity of the area to look for those sparse point clouds, but it gives you a hint, okay, there's 10 anchors in the area. These are some you should search for. So the Azure Spatial Anchors service, so it's designed to only store data that can't be turned reverse engineered into a meaningful 3D mesh. So it's meant to be like really non-human readable data, but also you can't read that data as a developer. You can never get the point cloud back. You're kind of testing against it, but you can never say, hey, let me see the point cloud of someone else's space. That's all kept within the service. You're never able to extract it. But I mean, it is definitely sensitive data and can be very personal data in terms of real world location. So I guess the responsibility is on you as the developer to say, okay, who am I giving access? Who's getting access to these anchors? And to make sure that so to get access to the anchors, you have to get access to that specific instance of the Azure Spatial Anchor service. So it's up to you to control, okay, who has access to that data. Yeah. No other questions? Okay. No. Did that answer it? Yeah. Okay, great.